Thank you for joining this lesson. We're going to discuss Mathematics Paper 2, Longitudes and Latitudes. A plane leaves P, 75 degrees north, 30 degrees east, and follows the longitude via the North Pole, flying at 300 knots to Q. It takes 10 hours to reach point Q. Calculate, Roman 1, the distance covered by the plane in nautical miles. For us to get distance, now that for the plane, we are given the speed in knots and time taken in hours, then we can use speed times time. This is going to give us with a speed of 300 for 10 hours. The distance covered will be exactly 3,000 nautical miles. So that is distance. Then in the second question here, we are finding the position of Q. Remember, we are having distance, and distance along a great circle and in nautical miles is usually given by beta times 60. This one is difference in latitudes. Therefore, if we got the two places, we just sketch. That is the prime meridian. This is equator. Now, this is 75 degrees north. Then now, we have 30 degrees in the east. This is 30 degrees in the east. This intersection now gives us our P. Now, for us to go to Q, we are going through the North Pole. So from P upwards, through an angle that we don't know until we cover this distance known here. Therefore, 3,000 equals to 60 multiplied by beta, and we can get the beta there. So this is going to be, when we take 3,000 out of 60, this gives us exactly 50 degrees. So from 75 degrees north, 50 degrees upwards, it means we will cover, first of all, the 17 degrees, the 15 degrees remaining, so that we reach the North Pole. Then we continue downwards now for some 35 more degrees, 35 more. Therefore, we are flowing 15 and 35 more down. That means we will be on the other side, and from 90, when we subtract the 35, we'll find ourselves now at 55 degrees, still in the north. Then now, the longitude is, if we are using 30 degrees east, then we should go down through 150. Those are called complementary longitudes. If we are following the poles, for instance, we are having the North Pole in this case. If we are flowing through 30 degrees in the east, when we go straight and continue with the same path, then we'll go down through the other side of the hemisphere, but now this path will be 150 degrees now in the west. Therefore, we're going to have position of Q being 55 in the north and 150 degrees in the west. 55 in the north, 150 degrees in the west. So that technique has to be understood. The 50 calculated here is being applied such that the angle difference is of 50. Therefore, we are going 15 because we are already at 75. So when we go 15, we'll reach the North Pole. Then down the 35, which is remaining, we'll find ourselves at 55 north. 55 north, because the 35 is counted from 90. So that means from 0, if we have a 35 here, from 0, that will be 75. 75 in the north. 55 in the north. That is the position of Q. We can proceed now. After spending 2 hours at Q, it then flies westwards to T. It flies westwards to T, which is 1,360 kilometers west of Q. Find the longitude of T to the nearest degree. Therefore, we have distance in kilometers, and now the plane is going to move. Let me sketch that information very fast. So we're going to move from 150, which is in the west. This is 150 in the west, and we continue moving to the west. Such that we are going to cover a distance of 1360. It should be known that distance along a small circle, we're going to have it as theta over 360, 2 pi r cosine of the latitude. A distance of 1360 will be equal to a non-theta longitude difference over 360 times 2, 22 out of 7, 6370 cosine of, we are at latitude 55 degrees. So for us to get now, we need 1360. We multiply it by 360 and also by 7. Then we divide by 2 by 22 by 6370 cosine of 55. This is going to be 21.28. 21.32, sorry. But now we've been taught to the nearest degree, so it will remain 21. Therefore, when we move for 21 more degrees and we are at 150, then we will find ourselves at longitude 171 in the west. That means the position of T is going to be, we were moving along 55 north and we have gone up to 171 in the west. So this is going to be degrees. This is going to be the position of T. That is going to be the position of T. Finally, find the local time at T when the local time at Q is 5:30 p.m. So we should know that T is in the west of Q. Therefore, T is behind in time. And the longitude difference is what gives us the time difference. For every 1 degree in longitude, there is a difference of time of 4 minutes. That means for the difference of 21.32 degrees, there will be 4 by 21.32 minutes. This is going to be 85 minutes. 85.27 minutes. So we're going to have these minutes are going to be this is 1 hour and 25 minutes. Can ignore this the seconds part. Therefore, we have 1 hour 25 minutes time difference. But now time in Q is behind by this difference. If T was in the west, if T was in the east of Q, then it could have been ahead in time. But now that it is to the west, then it is behind in time by this. So we subtract. When we take 5:30, and we subtract 1 hour 25 minutes, I will get 0.5. Then this is going to be 4. So it is 4:05 p.m. the same day. Thank you for following. Subscribe and share.